The Coriolis effect is named after Gaspard Gustave de Coriolis, the French mathematician who in 1835 proposed that the Coriolis effect applies to surface winds. It is the apparent tendency for a fluid or air mass moving across the Earth's surface to be deflected from its straight line.
Go! Move your pasty white butt. Come on, Shampoo, you can do it! Yay! I won your stupid bathroom products race! No fair. You only won because you had the inside track. If the water was spinning the other way...
It never spins the other way. In the northern hemisphere, water always drains counterclockwise. It's called the Coriolis Effect.
Well, not quite. What produces the Coriolis effect? The answer is the Hadley cell. The Hadley cell cycle starts at the equator where the warm air rises and travels either north or south until it collides with the cold air coming from the poles. This boundary where the warm air from the equator reaches the cold air from the poles happens approximately 30 degrees north or south. This is how the Tropic of Cancer, which is north of the equator, is determined, just as the Tropic of Capricorn, which is south of the equator. At the Tropic of Cancer, the current north of it goes from west to east, which are called westerlies, while the current south of it goes from east to west, which are called easterlies. The area north of the equator creates a clockwise rotation because of the current being deflected to the right from its original path. At the Tropic of Capricorn, the current north of it goes from east to west, which are called easterlies, while the current south of it goes from west to east, called westerlies. The area south of the equator creates a counterclockwise rotation because of the current being deflected to the left from its original path. A widely known example of the Coriolis effect in action is the hurricane, which only thrives in subtropical latitudes. Since the origin of the hurricane determines its rotation, a hurricane cannot pass through the equator because the rotation would be the opposite of what it needs to continue spinning, which would kill the hurricane.